In this lesson, we're going to apply the properties of positive and negative exponents. All right, so how do we apply the properties of the positive and negative exponents? First of all, remember that when we multiplied exponents, that we added the exponents, and these are when you're multiplying the exponents of the same base. We're going to add the exponents. So for example, if I have a to the third times a to the fourth, I would add the 3 and I'd add the 4, giving me a to the 7th. Because really what that is I've got 3 a's and then I've got 4 a's, and I put them all together and I have 7 a's. Same thing goes if I have 4 squared, or 4 to the second power, times 4 to the fifth power. I've got 2 4's and I've got 5 4's. And so when I put them all together, I have a total of 7 4's. Now, remember when we learned to divide exponents, that we said that we subtract the exponents. So for our first example there, that we have a to the sixth power divided by a to the second power. What that is I've got 6 a's on the top and I've got 2 a's on the bottom, and then we've got some that are going to cancel out. And so what it looks like is you've got a times a times a times a times, is that 6? I think so. And then I've got the 2 on the bottom. And so notice then that I've got 2 of those a's cancel out, and I'm left with just 4 a's. So we're subtracting the exponents when we divide exponents with the same base. So I'll have a to the fourth power. So when I have 5 to the sixth power divided by 5 to the fourth power, I've got 6 5's on the top, I've got 4 5's on the bottom, and then we've got all 4 of those that are going to cancel out, and so we're subtracting the exponents, giving us 5 to the first power, or we could just say 5. What's important that you don't do, though, is you don't take the 5 divided by 5. We're keeping the base, but we're just subtracting the exponents there. Now, when we have negative exponents, we are going to be, to make the negative exponent a positive, remember we are going to take its reciprocal, or we're going to flip it. So remember when we have like a to the negative third power, that to make this positive, that we had to flip it, making it the reciprocal of a to the third power. Now, when you do take the flip, remember that the exponent becomes a positive. So when you bring that negative exponent down to the bottom, it is now a positive exponent. So the same thing right here, if I wanted to then take this negative exponent to make it positive, I'm going to bring it down, giving us the 1 all over 3 to this positive 2 power. And then remember, whenever we have anything to the 0 power, it is always going to be equal to 1. What that looks like is if I had, let's say, a to the third power divided by a to the third power, I would have then 3 a's on the top, I'd have 3 a's on the bottom, and these are all going to cancel out. And when they cancel out, it just makes 1. And so a to the 0 power is equal to 1, and a 5 to the 0 power is equal to 1. And so I guess we could say that the rule is always equal to 1. All right, so let's go ahead and simplify the expressions, and we're going to write our answers using only the positive exponents. Now, that doesn't mean a positive number, it means a positive exponent. So these first few, we're just going to be looking at these. These are the ones that have got the negative out front, and that we have to determine if it's going to be a negative answer or a positive answer. So for the first one, I have negative 2 to the fourth power, and I don't have the parentheses. So we have to follow the order of operations, and I have to evaluate the 2 to the fourth power. And so it's like 2 times 2 times 2 times 2, and then I would get 16, but then I would have to put my negative back out on the front of it. Where if I have something like -2 in parentheses to the fourth power, it's like -2 times -2 times -2 times -2. I have 4 negatives, and so therefore it's going to be a positive 16. Now for the next one, we would just evaluate 2 to the fourth power and we get 16. And again, just like that first one, we're just going to put it out in the front. Now, if I have 3 negatives, well, remember, negative times negative times negative, that's going to remain negative. And so I have a negative 27 here because 3 times 3 is 9, 9 times 3 is 27. You would get the same answer as if I had had -3 without the parentheses. So the odd number of exponents, it doesn't make a difference, but it does make a difference where you've got the even number of exponents. All right, so number 5, again, we're just going to evaluate what we have here. 3 times 3 or 3 squared is 9, and we put our negative back on the outside there. All right, so now we're going to then apply some of these multiplication rules. So remember, when you multiply by exponents of the same base, we add the exponents. So here what we want to do is we're going to multiply our numbers like we always multiply them. So if 8 times 3, which is 24, and then when we multiply the exponents of the same base, we have to add those exponents together. So we're going to have y to the 6th power. All right, for number 7, I have 4x to the 6th power divided by 3x squared. Now notice that I can't divide these evenly. I'm just going to leave it. I'm going to leave the 4 on the top. I'm going to leave the 3 on the bottom. Now I could have just made the 4/3. That would be fine too. And then I'm dividing x to the 6th power divided by x to the 2nd power. That's going to give us 4 x's, so it's going to be x to the 4th power. All right, number 8. We're going to take 3 times 2 is 6. And again, we're going to multiply by adding together our exponents, so we'll have y to the 5th power. All right, question number 9, we have x squared divided by x to the 5th power. Remember, it's the top number subtracting the bottom number. So if I took that x squared and I subtracted the 5, so I take the 2 minus 5, that's going to leave me with x to the -3 power. Now remember, if you've got a negative exponent, we take the reciprocal to make it positive. We just flip this down. So on the top, we'd have a 1. On the bottom, we have the x to the 3rd. Now, something else you could do for this one is you could take and you could say, well, I've got these 2 x's on the top because I have x squared. And then I've got these 5 x's on the bottom. And now if I go and I look at these, I'm canceling out 2 of them. And now I do need to have a 1 on the top. Notice how we've got the 3 x's on the bottom. I've got 1 all over x to the 3rd. That's just another way of looking at it. All right, so for number 10, I've got 5x to the 3rd divided by 15x to the 6th power. Well, for this one, let's just go and 5 can go into 5 one time, 5 can go into 15 3 times. So let's leave that then as a 1 on the top and a 3 on the bottom because we just took 5 divided by 5 and 15 divided by 5. Now, take a look here. I've got x to the 3rd divided by x to the 6th. So if I am going to be dividing them, remember you're subtracting, and 3 minus 6 gives you an x to the -3. Well, remember, we don't want a negative exponent. So this is the only part I have to bring down. I would bring it down like this, and I would have 1 all over 3 x to the 3rd power. Now, again, another way of looking at this one is you could certainly go, and so here's the answer to this one, and this was the answer to this one. All right, now question number 11. Now, if you've got multiplication and division going on both in the same problem, remember we have to simplify everything on the top, and then we can simplify everything on the bottom. So let's go ahead and we're going to take our 2 times 3 like we always do, and we get 6. And then our x to the second power times x to the third power. Remember, we're multiplying exponents at the same base, so we add them together, and then we have 2x on the bottom. And I always go put a 1 there so you know that when you're dividing that you're going to be subtracting that 1 there. So let's take 6 divided by 2, and we get 3. And we're going to divide exponents at the same base, so we're going to have then x to the 4th power. So we subtracted those there. All right, our last one then, we have, let's multiply the numbers at the same base. We're going to get 12. Multiply the numbers then. So I'm going to be adding these together. So I get x to the 5th power, and I have 2x to the 5th power. Now, notice you've got x to the 5th divided by x to the 5th here. Remember, those all cancel out and give you just 1. Remember, anything, if I were to subtract 5 from 5, I get 0. So anything to the 0 power is just equal to 1. So really what just happened to those x's is they just canceled out. And I take 12 divided by 2, and I get 6. So in this lesson, we took a look at reviewing the exponent properties.